Good morning. I just called over to the cafeteria, by the way, and told people to stop eating and get over here. So I know we've got more folks on the way over. I hope you guys enjoyed yesterday. Everybody I talked to said, wow, I learned so much stuff, and it was so great to be in the presentations. And I just want to say that it's been a real privilege to have our K-12 and our higher ed folks all together in one place, and seeing where our students come from and how we can support their entrance from a variety of different school environments into our colleges was really important. So I want to thank you for partnering with us and bringing our K-12 brothers and sisters into this conference with us. I think it's really important for our students in California and our online students who come from everywhere for you all to have this experience. I get to introduce our speaker for this morning, and I'm really proud to have her here, or maybe just excited and proud. I don't know, there's a different meaning there. I admire her for what she has done. About 5 years ago, I discovered the Carnegie Mellon Open Learning Initiative. And I can't remember what I was looking for, but I was on one of those, one of those things you get on when you're researching for your courses, and you end up going to places you didn't expect to go to. And sometimes it's wonderful, and sometimes you kind of wake up 2 hours later and wonder, what was it I started doing? But in one of those discoveries, which you should probably take part in for yourselves on a regular basis, by the way, I found the OLI and Carnegie Mellon in general and the technology program there. And I remember thinking at the time, if I could go back in time and do my education over again, I'd love to be a student at Carnegie Mellon. I'd go back and probably, hawk everything I own to get back there and do that. I sent some of the information to my daughter who lives in Raleigh, and she's desperately trying to find her way to get there to go to school, so we'll see what happens with that. But you should visit, definitely visit and see the wonderful resources and information that's there. I've been telling folks about it since then, and I think that you will enjoy this morning's presentation for all of the resources that are there and how you can get involved. And so I get to introduce Candace Thille, sitting here, who is the director of the Open Learning Initiative at Carnegie Mellon and has been the director since the beginning in 2002. She also co-directs OLNet, which is the Open Learning Research Network between the UK and Carnegie Mellon. And she's been on the task force writing the National Education Plan for the Obama administration. And she told me this morning that she came in from San Francisco this morning. She lives somewhere between San Francisco and Pittsburgh, and actually probably on the plane between those two places. She'll go back to San Francisco today, and tomorrow we'll go to Pittsburgh, and Tuesday to DC, and then Tuesday afternoon to Detroit, and then maybe come back home. I think that was the end of the itinerary where we got. So she's on the move and very busy, and it is my pleasure to introduce to you Candace Thille. Thank you.
Good morning. So thank you so much for inviting me to speak with you today. I feel very passionate about education because I believe that education is the engine for social change. And so I admire the work that you're all doing, and I hope we can find ways to work together. One of the things One of the things I'll be talking about today is the importance of using data and evidence in designing educational interventions. And there'll be a theme that I'll just keep hitting on over and over again. And it doesn't matter whether you're teaching kindergarten through 20. I think the ideas that I'll be presenting and discussing with you today will be material for you. So let me start off by just waking you up a little bit to ask you a question. So how many people here teach algebra, math, anything in those? Okay, so some folks do, some folks don't. So let me ask you, which problem type is most difficult for a beginning algebra student? And by beginning algebra student, I mean a student that's maybe started in September and is like in March of their algebra class. So I've got 3 different problems there. The first story problem, which is, as a waiter, Ted gets $6 per hour. One night he made $66 in tips, earned a total of $81.90. How many hours did Ted work? Or the word problem. Starting with some number, if I multiply it by 6 and then add 66, I get 8190. What number did I start with? Or the plain old algebraic equation. X times 6 plus 66 equals 81.90. Okay, so as you can see, they're essentially all three the same problem, right? They're just different forms. So let's do, by show of hands, how many people think that the hardest thing for a beginning algebra student is the story problem? Raise your hands high. Okay, great. How many people think it's the word problem? Okay, great. Folks who are participating online, you can raise your hand even though no one will see you. And then how many people think it's the equation? Okay, great. So you might have known, I'll tell people who are participating online that we had a pretty even distribution, I think, in the audience here, with, I would say, most people saying word problem. You know, all those Far Side cartoons that say, word problem in hell. So does anybody want to say, for somebody who picked word problem, why do you think the word problems are so hard for students? Just, you can go ahead and shout it out and I'll repeat it for the people online. So why are word problems hard? Okay, because they're abstract, they rely on a command of language students don't have. Anything else? You have to find what the equation is. Okay, you have to take the word problem, translate it into the equation, and then solve the equation. Any other reasons? Okay, great. How about people who thought that the word problem was the hardest? Oh, excuse me. Did I say word problem or story problem first? Okay, so we'll try story problem. So people who thought the story problem was the hardest, why that? Yeah.
It's because there are more words to it, and there's a little bit more language to it, and a little bit more interpretation that goes with it.
Okay, so there are more words to it, more language, and more interpretation that you have to go to even get to the point of the... And less logic, okay. Others? Anybody else? Yeah. Okay, it's close to real life, so it's harder for students to take that real life experience and make an abstraction. Anybody else? Okay, so people who thought the equation was the hardest. Anybody want to say why? Okay. Okay, because there is no language, it's all logic. Anybody else? Okay, all reasonable explanations. And in fact, when we started to do this research to answer this question, we weren't actually doing research to try and answer why is this hard. We thought we knew what was hard. And what we were trying to understand was what made it hard so that we knew how to teach students. But in fact, in the process of doing the research to try and figure out what made it hard, the way we did that research was to take bunches of students that were beginning algebra students and give them assessments that had these different forms, matched forms, and then look at what they did to see what was hard. And we were really surprised because what the data told us that for those beginning algebra students, the story problems were actually the easiest. And the equations were actually the most difficult. Now that's surprising. It's surprising to us too. And the reason for it is because I think someone said when we're talking about what made word problems and what made story problems difficult, we were making the assumption that how students were going to go about solving the problem was the way we, who know algebra, go about solving the problem, which is you take the language, you translate it into an abstraction, and then you solve the equation and translate it back. But we found out by watching students that beginning algebra students who are struggling with algebra, that's not how they solve algebra problems. How they solve them is they take that first problem and they go, okay, that seems like it's maybe about this, and they keep a bunch of trial and error. They're not using algebra really. But they use a lot of their prior knowledge, the familiar context, to think about what makes sense in my prior knowledge. And that's how they solve the problems. In fact, we did eye tracking studies where we had students, where we gave them a screen, and there was the story problem was here. We asked them, as the first step, to translate the story problem into an equation and type the equation in down here. and then write the answer to solve the equation over here. And when you do the eye tracking, what you see students do is they read the story problem and they work like this. Their eyes go like this as they're working on the equation. But once they create the equation, when they then go to answer the question, they never look at the equation again. Then they go back to what they're used to doing, which is using the story to solve the problem. And this all brings about the point I was trying to make, which is what Ken Kadinger, who did this research, coined as the expert's blind spot, which is our expert intuitions often get in the way of our being able to see what novice students are going to struggle with. And in fact, then they did this test that I just did with you, with teachers at all different levels, which we probably have here in the room. We looked at, asked elementary school teachers, middle school teachers, and high school teachers all the same question that we just asked you. And in fact, the elementary school teachers were most often the ones who got it correct. Why? Yeah, they're probably closer to the novices in terms of they're not using algebra and teaching it and thinking about it all the time. So they're not as likely to have that expert's blind spot. So I bring that up not to just sort of drive home the point about how important it is that the more expert we are, the less likely we can be to trust our intuitions about how to design something so a student will understand it. So that brings me to what the purpose of my project is. The project that I run is called the Open Learning Initiative. And as Pat said, it started in 2002 with funding from the William and Flora Hewlett Foundation. And the foundation's goals at that time were to create open educational resources. Another big project they funded about a year before mine was MIT's Open Courseware project. How many of you have heard of Open Courseware? Yeah. That was a really, really well publicized project. And the idea behind OpenCourseWare was to take the material that was used at MIT to teach the traditional courses at MIT and make those resources openly and freely available. So the only thing my project really has in common with that project is that we make our resources openly and freely available. But the goals of my project are different. We're not trying to just create the materials that support traditional instruction, but rather think about how do you create online courses and resources that actually support students to achieve the learning outcomes that would be expected of a student sitting at Carnegie Mellon. And that takes a very different design process. So we bring together teams of faculty subject matter experts, learning science researchers, software engineers, human-computer interaction specialists, and we bring them together and give them the task of, given these learning outcomes, how do we use the affordances of the technology to design an environment that will support a novice learner to achieve those outcomes? Different design goal. And I kind of wondered, I asked the Hewlett Foundation what subjects. They said, we don't care. Do whatever subject you want. So the original idea, so one of the first classes we did was introductory statistics. And I think that's because we all know that it's a real human drive to want to do statistics. So the individual learner out there who's like, oh, by gum, I want to learn statistics, now has a place they can go, even if they don't have the privilege of going to one of your institutions. They can go online and hopefully achieve the same learning outcomes as a student sitting in the comparable course at Carnegie Mellon. So we call these scientifically based courses. And by that, I don't mean that they're all science courses, although because it's Carnegie Mellon, a lot of them are, but that we use a scientific approach to the course design. Then to provide open access to the courses, and also to the third bullet, which is where you all come in, to develop a community of use, research development that contributes to the ongoing evaluation and improvement of the course. Okay, so what do I mean by scientifically based? Well, one of the things I mean is that we take, first, we start with a theoretical underpinning, and that's the theoretical underpinning that's given to us by research in the learning sciences. So we take all that research literature and we extract principles that we use to inform the environment's design. For example, one of the things we know from learning science is that goal-directed practice and targeted feedback are critical to learning. So how does that inform the design of something? Well, I'll give you an example out of one of our courses. This is out of our engineering statics course. And so I don't know, can everyone see that? So this is a problem. So we give the students some instruction. Then there are many places throughout the courses interspersed all the time that are what we call "Did I get this?", which is the student's opportunity to try and to put into practice what it was we hoped we just taught them. So this particular practice opportunity is summing concurrent forces. So we've given the student 3 different vectors. And we ask them the simple question, what's the magnitude of the sum and what's the direction of the sum? So I've done a little screen capture here of a student working through the problem. So the first thing the student can do is they can try working it out on paper if they want, and then they can just go ahead and type in their answer. The system immediately tells them whether it's right or wrong, turns red or green. They can ask for a hint. The system says, the purpose of this is for you to assess yourself, but if you need some help, click here. It tells them, remember, the first step in resolving this problem is to resolve each of the forces into its component parts. So then they can try what's the force of the first component, and again, if they struggle, they can ask for hints. As you can see, the hint sequence scaffolds them through the thought process we want them to go through when they're trying to think about that problem. So it's context-specific feedback. It's not just yes, no. It's, if you're struggling, think about this. You need more help? Think about this. You need more help? Think about this. Until you may have noticed the last hint was essentially it's 4.16, so that the student can answer the question and keep moving. Now, I fast-forwarded here to the student having completed the problem. And now this student has used a lot of support and help to get to this point. You can tell because the tutor is fully expanded. They've gone through all 4 steps. They've probably used lots of hints and feedback to answer each sub-step. So the system recognizes that and says, great that you were able to do that, but really, you should be able to do this without all that help and feedback. So why don't you go ahead and click here, and you can try again. And the system will then automatically generate a completely new problem. The graphical representation changes, everything changes. All the hints and feedback change to the new problem. This basically gives students 24/7 support in the context of solving this problem. So I will just go to, okay, so that thing that I just showed you, we call those mini tutors, and they're all over the OLI courses. And they're built on research that's been done for about 15 years at Carnegie Mellon in the area of cognitive tutors. Now, cognitive tutors are basically just attempting to use the affordances of the software to give the student the kind of support they could get from a human tutor. A good human tutor, I should say. So when the student's moving along and answering questions, it doesn't interrupt them, it just lets them move. It'll give them feedback at appropriate times when they need it, and it's always there to answer a question if they need a hint, but they can ask for it. Okay, so that's one principle. A couple more principles and a couple more examples. Other things that we all know as teachers is that meaningful engagement is necessary for learning, and also that mastering a topic area or subject area is more than just accumulating a bag of tricks. So what's great about that isolated statics tutor that I just showed you is a student, after working with that, really will develop very good procedural fluency in knowing how to sum vectors. But when we want students to get the idea of statics, we want them to have more than just this little bag of tricks. And we know that students, especially in introductory courses, when they're overwhelmed with all that knowledge and concepts and skills, tend to compartmentalize. And so, we've done all kinds of research, which I'm sure you would be validated by your experience, that you can give students lots of instruction, and then on a test, you ask them something that has them pull together all those bits of knowledge, and they can't do it. Because they don't get that problem that you're giving them, actually they have the tool, they have the resource to apply to it. Unless you say to them, make a box plot. They don't know that making a box plot would actually help them make traction on that problem. So part of what we really work on in designing our environments is helping give students what we call a big picture, a structure of the knowledge that they can hang all those pieces on. The way we do that is, for example, in our chemistry course, the first thing we do is we replace the paper and pencil homework problems with virtual lab activities. Now, the virtual lab is not intended to replace a wet lab. It's intended to replace the traditional paper and pencil homework problems. Because what we see students do, sort of a shallow means-ends analysis to solve traditional chemistry problems. They take the equation that they're given on the homework, they flip through the textbook, they find the equation that matches that, they plug the values in, they solve the problem, and they have no idea what that has to do with chemistry. The other thing that we see them do is even when they get the chemistry-mathematics connection, they often don't get how that fits to the real world. So we teach them stoichiometry in the context of this real-world problem, which is the arsenic contamination of the water supply in Bangladesh. So the first thing the students are given is this problem. They're put in the role of chemist, and they're given a well sample from an arsenic-tainted well in Bangladesh. And the first question they're asked is, how much arsenic is in this water, and is it safe to drink? So they can do the little chemical analysis there, and you can see here, it tells you how many moles of arsenic are in that solution. Unfortunately, if you look at the World Health Organization's recommendations for safe drinking water, the World Health Organization doesn't say how many moles of arsenic are safe. They say how many micrograms per liter of arsenic is safe. So, and even to answer the very first question, they have to be able to do that conversion, converting from moles to micrograms per liter. So again, they can just go ahead and try typing it in. And if the little hints and feedback aren't enough, then we put them into a just-in-time learning experience, where we give them little walkthroughs. This is sort of a voiceover. There's no sound for people that are listening on the online thing. The only sound is me. And then we give them worked examples. And then we give them tutored problem solving for practices, just as you saw with the other ones. And again, in this case, the scaffolding for the problems decreases as they work through them. Okay, so the big point here is that the feedback the students get as they're practicing in the context can actually change the productivity and the effectiveness of their learning. But the other thing that you're not seeing that's happening there is as the students are working in the environment and they're getting all that feedback, the other thing that we're doing is we're collecting all that data about what they're doing, and we can make inferences about what they're learning. And we can give that information to you, the teachers. How does that work? Well, let's say I meet with my students on Mondays and Wednesdays at 10 a.m., whether it's online or in a classroom. So normally what you might say to your students is, go work through this textbook or go do these practice problems or something, and do that before we get together next Monday. Well, change that to say, here it is Wednesday morning, and instead of saying work through the textbook, I say work through the OLI Module 3. And finish working through OLI Module 3 by 10 o'clock Sunday night, because we're going to meet at 10 a.m. Monday morning. So 10 o'clock, so the students work through the module, they're getting all that feedback and support as I showed you. Then at 10 o'clock Sunday night, I, as the instructor, log on to the system and I look at the instructor feedback reports. And what that tells me is, for the learning outcomes that I wanted the students to achieve by working in that module, I can get a quick view of where are they struggling and what are they getting. And I can click down to see more detail about specifically what of that outcome, what are they struggling on? What are they really missing? And then I can use that information to spend what I think of as that very precious time with the students, where they're interacting with the instructor much more effectively. And that's why I call this the killer app. Because really, I mean, online environments are great for many things, but I would put forth to you that the most powerful feature of web-based learning environments is that we can embed assessment into virtually every instructional activity. And we can use the data we collect from that assessment to drive 4 very powerful feedback loops for continuous improvement. The first feedback loop is obviously to the student, which we already looked at. And what's key there is that the student gets the feedback at the time they need it, when they have the opportunity to use that feedback to refine their performance. Because right now, in sort of traditional feedback loops between instructors and students, what happens? You give the student an assignment, they do it, they turn it in. Even when you spend a lot of time and energy giving them very careful, well-constructed feedback, they get it back a week later, 2 weeks later, when they've moved on to a completely different topic. And even if they look at the feedback, which I don't want to, maybe they don't, but even if they look at that feedback that you laboriously gave them, they might be sitting there going, I don't even remember what I was thinking when I wrote what I wrote. So that feedback isn't hitting me when I need it to actually, and then even if I do get it, then the chances that that student's going to use that feedback to then try that problem again, to use that feedback to refine their performance are pretty small. So that's why the importance of the immediate and context-specific feedback, so that students can use it again to refine their performance. Then the feedback to the instructors, as we talked about, so that you can use that very precious time that you have with the students to really target what they need and not spend a lot of time on things that they don't really need. And then the other 2 feedback loops, which I won't talk that much about, are one is to our course design team. As I mentioned, all of our courses are designed by these big collaborations. So we use the data that we collect, not just from an individual class, but from the classes all across the country that are using that learning environment. That's a huge data source to help us target what's working and what's not working in the way we've constructed the learning activities. So the group can use that information to decide for the next semester where are we going to target improving the course. And then the 4th feedback loop is to the science of learning. A project that's the sister project to my project at Carnegie Mellon is called the Pittsburgh Science of Learning Center, which is one of those NSF-funded learning research centers. And they've been funded for 10 years for $50 million. And the purpose of the center is to essentially develop and refine our understanding of human learning. And they use the OLI environments as their research labs. So we have learning science researchers all over the world looking at the data that's being generated to help us understand better human learning. Or they can also use it, they also use the environments to sort of insert experimental conditions. And then students are learning and they're part of a big experiment that helps us understand learning better. So you might want to see what that data kind of looks like to the learning researchers. So this is what we call a learning curve analysis. So I'll get a little geeky here for a moment, because people like graphs. So the y-axis is what we call the assistance score. Now you remember back when you were doing, I was showing you that not the stoichiometry tutor, but the engineering statics tutor, and students could keep asking for hints. So I'm wondering if any of you were thinking, yeah, but if they keep asking for hints, then they're just going to keep doing that till they get the answer, and then they'll go on, and then they won't really learn anything. Well, the system is collecting exactly that information. So every time a student asks for a hint, or tries to type in an answer and gets feedback from the system that their answer was not correct, that's a function of how we calculate that assistance score. The x-axis is the number of opportunities the student had to demonstrate their knowledge on that concept. So this is the kind of learning curve we like to see, because it means at the very beginning, when they first were introduced to this concept, they needed a lot of assistance to show that they knew it. And then each of those dots is a practice opportunity. So over time, with more practice, the amount of assistance they needed to answer that question was less. So this is a nice, when we see these, we go, yay! We don't always see these. It's not uncommon to see a learning curve analysis that starts up there high on the y-axis and kind of bounces around, and by the time you get to that opportunity here, it's still high. What would that tell you? Yeah, they're practicing a lot because there are lots of opportunities that they're using, but the practice isn't helping them learn. So that's a real opportunity for us to sort of say, oh, we need to look at how we've structured that, what we need to be doing differently. Another kind that we get that we also don't like to see is starts low and bounces along and stays low. What does that tell us? Yeah, they kind of already knew it. So we're kind of wasting the students' time, giving them lots of opportunities to practice something that they knew when they started. So that would also be an indication that we need to change something. Then sometimes, and these are my least favorite graphs, it just is kind of like this random thing. And that one, usually what that means is we've specified the knowledge model wrong. The way we've tagged the activities, there's more than one thing in there that we can't really unpack, that we haven't unpacked well enough. Okay, so I'll do a quick review. So the big key points for OLI is that we apply learning science research and the scientific method to the course development, the implementation, and the ongoing evaluation. That the environments are not just developed by a single faculty member, but they're developed by teams because you need that variety of expertise to really develop effective learning environments. The faculty members, the learning scientists, the software engineers, the human-computer interaction experts, and we also have novice learners on the team. And then what I call the killer app, which is the feedback loops for continuous improvement. So you might be saying, okay, that all sounds great in theory, Candace, but really, what difference does it make? It seems like a whole lot of trouble to go to. Well, we do a bunch of studies to look at what difference it makes. And one of the studies that got a lot of press were these series of accelerated learning studies we did. And the reason that we did, I'll be honest, the reason I did the accelerated learning study, I hadn't set out to do accelerated learning studies, but a couple years into the project, my program officer, Mike Smith from the Hewlett Foundation, came to visit, and we'd done a number of studies already that had shown that students using the OLI environment learned as well or better than students sitting in the comparable classroom at Carnegie Mellon. So I was thrilled, because that was the original design challenge. So he came, I went, ta-da, look at these great results. And he kind of looked at me and he said, oh, Candace, that's okay. You're basically showing no significant difference. I'm like, yeah, that was sort of the point. And he said, well, if all this stuff you're telling me is true, that, you know, bringing the learning scientists in to inform the design, the 24/7 support and practice, you know, the continuous improvement, it seems to me that students using the OLI environment should do better than students sitting in the traditional course at Carnegie Mellon. So show me better, and I'll extend your grant. It's motivation. It's like, okay, Mike, how can I show you better? Because, you know, measuring learning outcome, for those of you who, you know, get into that, it's kind of, you know, it's such a sensitive thing. And he said, well, how about faster? There are a lot of kids in this country and in the world that are behind. And playing catch up is really hard. So if you can show that those kids can achieve these outcomes faster than traditional instruction, that would do it. So I went to my institutional review board and proposed this accelerated learning study, which frankly I was really surprised they let me do on real students. So we had students, and I had to make some concessions to how I would have chosen to do it. So what we did was we had students that were enrolled in the traditional statistics course. I got the roster of students who had registered for the course about a month in advance, and I sent out an email to all the students and said, we're doing this study. If you want to be in the, and we're going to see if you can learn the material in half the time with half the class meetings a week. If you want to be in the study, fill out this survey. Within 24 hours, half the students had filled out the survey. So it was good, because I had a nice sample then I could randomly assign, of the students who filled out the survey, I could look at all the demographic information, and then I randomly assigned those students to condition. So thank you for volunteering to participate in the study. You are in the accelerated group. Thank you for volunteering to participate in the study. You're in our control condition. Go to class as you registered for it. And then I also had the students as a control who never volunteered. So I had 2 control conditions in an accelerated group. And the results were, so the accelerated group used the OLI statistics course. It did not get a textbook, no other materials, just the statistics course. And they met with an instructor 2 times a week for 7.5 weeks. The students in the traditional course got the textbook, all the same things, and they came and met with the instructor 4 times a week for 15 weeks. All three conditions did a pre-test and a post-test, and they all did 3 midterms and a final. And the results were that the OLI students did complete the course in 7.5 weeks. They showed actually significantly greater learning gains than the traditional students, even though they had half the contact hours for half the elapsed time, on a standardized test of statistical literacy. This was not a Carnegie Mellon created test, this was somebody else's research project. And there was no significant, and so we thought, whoa, this is kind of astounding, but we all know that if students cram and learn things faster, they're gonna lose it faster. So to address that concern, we did this study in spring. We brought a sample from each condition back in the fall and did a retention study where we gave them the standardized statistics test, and we also gave them a new statistics problem to solve and some other things, and there was no significant difference in loss between the OLI students and the traditional students, even though the OLI students had actually had a longer retention frame because they stopped taking the course in March and the traditional students didn't end until the end of May. And I should also say that the other question that I always get is, yeah, well, how do we know the OLI students weren't just cramming outside of class? So we did do, during the semester, samples with students to look at how much time they were spending outside of class studying statistics, and there was no significant difference among any of the groups. So then we thought, whoa, the results were so astounding, and we've published them in a paper which you can find on our website, that we've replicated the study 2 more times with virtually the same results. And I'll be presenting the results from the 2 follow-up studies next month in Slovenia at the International Conference on Teaching Statistics. So after that conference, then I'll also make that paper available. And you might say, the other thing I get is, yeah, okay, so that's Carnegie Mellon students. It doesn't apply to my students. So we do studies at other institutions, which you're all welcome to. If you want to participate with us in the research, I'm happy to do studies at your institutions. So we did some accelerated learning studies at community college. But the community college was more, I think, careful about their students than Carnegie Mellon was, because they wouldn't let me do it the way I had designed it. They said, no, students who've signed up for a 15-week statistics course need to take a 15-week statistics course. We can't tell them stop coming after 7.5 weeks. So instead what we did was, the way we got the acceleration was they were in class for the same amount of time, but they covered about 1/3 more material than the traditional class did. And they performed the same as their traditional students on the community colleges generated midterms and finals. So on the base material they were expected to know, they performed just as well, and they also learned this additional material. And then on this standardized test, which I was talking about before, they actually had a statistically significantly greater learning gain than the students in the traditional course. And then we did a study at a large state university where we looked at the OLI completely as this one's probably more interesting to you, completely as an online course versus the traditional course. And in this one, the end result was the same. Students who took the final performed about the same regardless of condition. But the significant thing here is there were 300 students in this study, about 200 in the traditional condition and about 100 in the online condition. And of the students who started the OLI condition, 99% of them completed it and took the final. And the students who took the traditional condition, only 41% of the students actually ever even took the final and completed the class. And then the final one is at a community college. We did an accelerated learning study using our logic course. And again, we didn't have the same kind of standardized tests that we had with statistics, but using their finals and their midterms, the students were able to perform as well, even though they covered about 1/3 more material in the same amount of time. Okay, and then we also do a bunch of data log analysis results, because one of the things that we're always looking at is, can we make a causal claim between the learning activities we designed and learning outcome? So one of our learning scientists does what she likes to call the dose-response analysis, which is looking at particular learning activities like that engineering statics tutor or like a chemistry lab that were designed to support students to achieve a particular learning outcome, and seeing if we can show a statistically significant causal relationship between doing that activity and learning gain, and not see that correlation between unrelated activities. And we've been able to show that. We've done those analyses on both the biology and the statistics course. And then this is one of my favorite data logs analyses. This is in our stoichiometry course, which I showed you a little bit. We did a analysis of traditional versus using the stoichiometry. And the thing that's very cool is those virtual lab activities that I was showing you explain 48% of the variance in increase in learning outcome. And it blew out all other predictors, including SAT score and gender. And anytime you can blow out gender as a predictive variable in a chemistry course, I get very excited. That's just me. Okay, then you might say, okay, well, that's great that it works, but do students like it? So we do these end-of-course surveys. And this question that this was answering was, if your best friend was taking statistics next semester, would you recommend that they take it this way, with the OLI way, or the other way? And 85% of the students said they would definitely recommend to their best friend to take it this way. 15% said they'd probably recommend, and nobody said, no, I think that the student should go sit in a lecture and read a textbook. And then we do open quotes. This is something one of the students wrote that was in the accelerated learning study. This is so much better than reading a textbook or listening to a when my mind didn't wander. I was not bored while doing the lessons. I actually learned something. And the student underlined the word learn when they wrote out the comment. And then you might think, okay, that's great for the students, but this is completely different for instructors, and doesn't it kind of make the instructor feel like you're taking away some of their teaching? So the instructor who was the first instructor working with the accelerated learning study, he was a real skeptic, believe me, before we started this, because he's a high-touch, high-relationship instructor, and didn't believe that he thought that using so much of the online and so little contact hours would really get in the way of his developing a relationship with his students. But at the end of it, he said the format was among the best teaching experiences I've had in my 15 years of teaching statistics. And when I pushed on him about why, he said, well, usually when I assign my students work to do before the next class, they go off. Some of them do it, some of them don't. I don't really know what they're doing and what they got. And I start my class and I just kind of hope that I'm targeting what they need. For the first time, the students came to class knowing what was expected of them, because they knew what the learning outcomes were. They'd gotten all this feedback, so they knew what they knew and what they didn't know. More importantly, I knew what they knew and what they didn't know. And probably the most importantly, they knew that I knew what they knew and what they didn't know. So we started that time together in an incredibly aligned position. And so it just made it feel much more like, even though he had much less contact time with them, a much richer relationship, which I imagine a lot of you teaching online also feel with your students, contrary to what a lot of people think about online instruction. So I put forth to you that this is a strategy for educational improvement, that to get better learning theory, we need better data about what's really going on about students' learning. And then to get better educational technology, we need better theory that's informing the design of the technology. And so we get this virtuous cycle of we design these educational technologies based on theory that generate data, which we can use to refine our understanding of learning, which we can then use to refine the educational technology. Which brings me to those of you who are in community colleges, because we've been doing this work since 2002 with kind of just a scattering of institutions in all different Carnegie classifications. But recently, at the beginning of this year actually, the Gates Foundation, the Lumina Foundation, and the Hewlett Foundation kind of came together and said, we want to see if we can use this approach that you're doing to address these terrible challenges we're having with access and completion at community colleges. So they funded this new project, which is a sub-project of the Open Learning Initiative, called the Community College Open Learning Initiative. And the goal is, the process is to bring together faculty from community colleges all across the country to participate in these development teams. And remember how I said that our teams are comprised of faculty subject matter experts, learning scientists, software engineers, human-computer interaction. Well, we have the same teams, but in these teams, the role of subject matter expert, faculty content expert is played by groups of community college faculty from a distribution around the country. And the goal is to work with those, on those teams to develop 4 gatekeeper courses, material to support 4 gatekeeper courses. And what we mean by gatekeeper courses is they're courses that have high demand, high enrollment, and are important to a major, completing a 2-year degree, or important to transfer to a 4-year institution, and that don't historically have great success rates, either because students just can't get them because there aren't enough sections, or because even when students get them, the pass rate isn't that great. So the 2 courses that we're doing first are an adaptation of the statistics course and a new development in anatomy and physiology. So anybody who's working in those areas who'd like to participate in those 2, please see me after the meeting. So the idea is, the goal is over 3 years to show a 25% jump in successful course completion rates in those areas where we're designing these environments. And we have about 40 colleges participating in the CCOLI course development and adaptation and evaluation. And what I'm really trying to do is see if we can put together a model for experimenting with and testing and improving innovation. Because I think the problem isn't out here that there's not enough innovation going on, that there aren't enough. The problem is not that we don't have enough teachers that are committed and trying and doing really interesting things with their classes to help their students learn. The problem is that this teacher's doing it, this teacher's doing it, this teacher's doing it, this teacher's doing it, and it's happening in 1,000 classrooms or more in these isolated little contexts, and no one's getting to build on or benefit each other's work. And also, even sometimes that own instructor doesn't get to build on benefit because they don't have a way of knowing, really, of the things that I did, what really worked to support the students' learning and what was just sort of fluff or noise. So what we're trying to do is create a structure where we can take this sort of scientific, evidence-based approach to both developing, disseminating, and refining learning environments. And this is, for those of you who, my eye doctor paid for me to put this slide up, because you need his services to read it. This is sort of the structure of CCOLI. So we have these 2 course developments going on right now. One's a brand new course development, anatomy and physiology. One is an adaptation of the existing OLI statistics environment. So you can see what we have on each team. We have, well, there's actually more than 3, but that's good enough. But the little S's are the subject matter experts from the community colleges. And then we have a course developer that's running the team, and we have learning scientists and assessment specialists and technology support. And that comprises the core development team. Then the next ring out, the people in the next ring out, are what we call our review and contribute group. So those are faculty that maybe don't have the time or energy to participate in core development, but are teaching in that subject area and want to review the learning outcomes, review the material as we're developing it and give input, or have a particular activity that they do that they find is really useful to help students to really get skew when you're looking at a histogram, that they want to contribute to the project, and then we'll work it in. And then the third ring out is probably the biggest group, which we call the use and evaluation group. Those are faculty that are teaching in that subject area that want to use the material to support their students' teaching, and we'll collect data on what their students are getting. We'll also interview them to find out what's working and not working for their students, and what kinds of moves they make in the classroom to support their students when the stuff that we've developed hasn't supported them. And we also use them to continuously refine those instructor feedback reports, because that's another active area of research. Then we have these, the little 3 people in the middle are the, what we call the regional network coordinators. So these institutions that are participating are all over the country. And so the regional network coordinator basically attends to the institutions in their region that are participating to make sure that the implementation's going well, that that kind of stuff. And then that all reports to me, the CCOI director, who is supported by a steering committee. So I have this advisory board that basically helps us figure out what courses to do and how to structure the system. And so I will remind you of something that you are all painfully aware of, is that the gaps between supply and demand for effective post-secondary education are just growing. And we can't keep up. And this chart, and it's disproportionately affecting different members of our population unfairly. So there's an economist by the name of Baumol, who back in 1967 wrote a paper called Baumol's Cost Disease, where he looked at certain industries where the cost of the service just escalates up beyond the sort of standard of living, every other price indicator. And one of the industries he was looking at was higher education. Because if you look at the cost of higher education over time, if you look at the trajectory of the cost of delivering that service compared to almost any other industry, there's a huge gap. And the other example he gave was a horn quintet. He said, you know, to produce a good horn quintet, to play a good horn quintet, takes 2.5 person hours. And any attempt to increase that productivity will have a detrimental effect on the quality. And the same thing was true, he thought, of higher education. And so far, he's been pretty much borne out that the more we've tried to scale the service of stuffing more and more students into classrooms, the quality has gone down. But I believe by really leveraging what we know about human learning and leveraging these technologies, we can address and mitigate Baumol's cost disease by more effectively using information technology and what we know about learning and blending it with faculty to use them more appropriately. So our message is, he said, advanced knowledge and instructional productivity without a complete revolution in our approach to teaching. We cannot go beyond our current levels of productivity. And our message is, we think such a revolution is possible, and our question to you is, who's going to lead it? So that's it, and I'll close with one more quote, and this was from Herb Simon, who was actually a Nobel laureate at Carnegie Mellon. He was also an economist, and he said, back I think this is in 1998, improvement in post-secondary education, and this I think is true for any level of education, will require converting teaching from a solo sport to a community-based research activity. And what I'm inviting you all to do is participate in that community-based research activity. Thanks. Thank you. Okay, so since it's a community activity, I'd love to hear your questions, comments on anything, and they have microphones. Where'd the microphones go? Oh, I can't see. Microphones at the side of the stage, and we ask you to use the microphones simply because we have a collection of people that are participating online, and if you don't use the microphone, they won't be able to hear your question or your comment. So just walk right up to a mic. There we go. No, can you make his mic live? While we're waiting for the mic to go live, I should also say that on the OTC10.org, go to that website, and there's a portal that you can enter a discussion for this session. And I'll be in airports over the next few days, so I'll check into that discussion. So if you either in person or the online folks, if you want to participate in that, do post and I will respond.
Thanks for the wonderful presentation. I just wanted to start with a quick technical question. I've recommended the stuff you're doing to my faculty, and was wondering about how you put together the modules. I really like the self-assessment at every stage of the process and so forth. Is that a proprietary sort of technology that you're using, or is it off-the-shelf technology that you're using to build your modules?
Okay, so the question, oh, I don't have to repeat it because everyone heard it. So the actual development and delivery environment is a system that we developed at Carnegie Mellon. And you might say, well, why do that? Why not use Blackboard or Moodle or something that's already out there? And especially at the time, and I think this is still true, to get the kind of communication among learning activities and sequence the learning activities the way that we needed to really support learning, the traditional learning management systems just couldn't support it. So we developed and also since it's a big research project, all the data collection piece. So we did develop our own environment for doing that. And the question has come up many times, since you're an open educational resources project, why not make the environment an open source environment and just let people go out and use it that way? We make anyone can use the environment. We don't charge you for using the environment, but we don't make the code open source. And that was something we struggled with, and frankly, it's because to make a good open source project, open source software project, we would need to be an open source software project. And that is, given the limited resources and time, where we really want to focus our energy is in the process and the methodology and the tools for developing effective environments, and not in making an open source software project. It also, I think, would communicate the wrong message. Because if we said, okay, the secret sauce to OLI is the software, that's not really what makes it work. What makes it work is the design methodology, the feedback for continuous improvement, the integration of learning science research. And if we just put the software, I actually have an example. I did create tools, these tutor, because all those little tutors, I thought, oh, you know, I could make the process shorter by just creating these tutor authoring tools and giving them to the subject matter experts and say, okay, here's how you use them. And we made them really WYSIWYG and Flash, so we actually still have them if people want to try it. But I have a set of tutor authoring tools, and they're basically Flash components. So that if you have Flash, you can just install the OLI tutor tool component suite into your Flash. Then you drag a little tutor shell onto your thing, and it automatically makes the hint button. It scaffolds you through what's your question, what's your first level hint, your second level hint, et cetera, et cetera, et cetera. Great. So I gave these to these faculty, and even faculty that are wonderful teachers. And I gave them this mnemonic to help them think about how to structure the tutor. So if you give the student a task to do, and you're going to write a hint, think about what would you say to the student if they were looking at that task and, like, needed a hint. I don't know what to do, give me a hint. What would you say to the student? Because I want them to give context-specific feedback. So I tried the first tutor. It was a lovely little tutor. I asked for a hint. The hint window came down, and it said, "Did you read what I told you to read?" It's like, okay, maybe that is what you would say to the student, but that's not exactly what we're trying to create here. The other one is on the feedback. There was one that one of the faculty was making for in probability, and they had given, and I tell them to choose, you know, distractors if they're going to do like a multiple choice thing. Choose distractors that represent a meaningful mistake, so that you can target a student's misunderstanding. And so they had put as one of the distractors 1.37 probability, and the feedback on that was give up. If you think probability can be bigger than 1, you've missed it completely. And it's like, that's not exactly the information I want to give students. So, I mean, so we're trying to, and also it also gets away, the other message that I think it would conflict with is my message of, I don't want everyone off in their own little isolated world, doing their own little thing, and not having everybody be able to benefit from that. So by not just making the software so everyone, because what I would hate to have happen is to put those tools out there and have 47,000 different sort of half-baked courses in the same subject area. I'd rather harness all that creative energy and have us all working towards creating an environment that we could collect data on and continuously improve, and that all students could benefit from. So it was a long-winded answer to your short question, and I hope that doesn't scare someone from asking another question. There's a little joke around Carnegie Mellon. Don't ask Candace what time it is. She'll explain how to make a watch.
I teach statistics, and I just had to say that I thought this is fabulous. I've been resisting the online statistics lessons, so I think this is great. On that note, I wanted to ask, a lot of your important conclusions are based on failing to reject the null, which is terrible in statistics world. Have you collected, as a statistician, there are other ways to collect data, correlations and things like that. Have you collected those data to show similarity between learning?
Yeah. I mean, there was, usually it's those tests that capture people's imaginations, but yes. And what we do, I mean, we collect data in lots of different ways. And with that, some of it is introducing different experiments, and then we're looking at comparing them. But we also just collect huge amounts of data that we use, are beginning to, not me, but the researchers in the Pittsburgh Science of Learning Center are beginning to use sort of educational data mining approaches to sort of look at patterns that we didn't even necessarily anticipate.
Another thing that might be nice is to add a control group that didn't take the class, because then if you are able to show a significant difference between, let's see, group A would be in your OLI, group B would be in a traditional course, and group C would be in your, had never taken a course. If you're able to show a significant difference between A, B, and C, but no significant difference between A, B, most statisticians would love that, because if you're able to show you have a significant difference, but it's not the groups that you don't want to differ are not differing. So you're able to show the power to find a difference, and therefore you have a difference, but it's kind of reinforcing the non-significant difference between the two groups. Because in experimental psychology, we would never accept null effects.
Yeah, so I'm not trying to show that there's no significant difference between the traditional group and the OLI group.
Oh, I thought on all the slides that the most powerful finding was that there's no difference in their comprehension, there's no difference in their retention. So these are all, I think, are awesome things, but they're basing it on the null. So it would really...
well, that's because okay, so I think I get what you're saying. So the hypothesis that we were trying to test was, could students using the OLI material achieve the same learning outcomes in half the time with 1/4 of the instructor contact hours?
I guess I was just, from a statistical standpoint, you can't ask the same question without doing a correlation. Are they going to be the same requires a correlation and not mean differences. But I think it's phenomenal. I think it would just be a matter of adding continuous variables that show similarity between the two groups and not contrasting learning outcomes. Because statistically speaking, you have no idea if it's because...
So we have pre-test and post-test. So the students, all the students in all three conditions took the same pre-test. So I know that their start state is the same.
Okay.
And we also did the demographic variables so that I can look at, were the samples, even though we randomly assigned them, on variables that are usually considered important, the same. And so that's the, so we use both, so that's why we use a pre-test and a post-test. So we're not trying to make a claim without showing a gain.
Awesome. All right, thank you.
Sure. Other?
Hello, I just had, from an English instructor perspective.
Great.
Especially with the recent budget cuts, and they hit remediation, disabilities, and English as a second language really, really hard. Is anybody doing something like this for that particular group?
Great, yes. So two things. One of them is in CCOLI, as I said, we're doing 4 courses. The advisory board has not yet picked course 3 and 4, but there's strong energy to either do sociology, psychology, or English comp. So you can vote. The other thing is that irrespective of what we do in CCOLI, in the Pittsburgh Science of Learning Center, which I mentioned is the Learning Science Research Center, we are doing an English as a second language course in the OLI environment as a laboratory research environment. So assuming that we learn interesting things about how to teach English as a second language, then that could be made available as an actual use and production environment. You next?
Hi, Dr. Candace. Thank you very much. You have really inspired me. I now want to make sure that my dissertation, when I complete it, has my statistics correct. And I have two questions. Is your research accessible now?
Yes.
And so we can access it whenever we want to?
Yes.
Okay.
So our website is, you can just, there are a couple ways to get to it, but you can go to www.cmu.edu/OLI, and you can get into all the courses there. You can also, there's a little tab called the initiative, and that's where all the papers are.
Okay, great. My other question was similar to the lady that just spoke. I teach business communication and e-commerce. At our school, Monterey Peninsula College, last semester, I taught the business communication course for the first time online ever that it was offered. The previous instructor felt that it could not be done online at all. But we were very successful with it, and so they've asked me to teach it again for this summer. So I've compressed 17 weeks into 8 weeks now. The interesting thing for me is that we're using Moodle, and it seems to have some of the capabilities built in for the automation of assessment for faculty and the students. And I'm just wondering how to integrate what you are doing so that we can do more than just collect the data and see a few graphs and charts of the progress of the learners. It would be good if I had been the one that taught the physical class, because we're training the knowledge workers for this paradigm that we're in now, and they'll be distributed and global and all those contexts. So I'm just wondering how can we maybe participate? I think that the soft skills are very important, particularly when we're talking about the language barriers and the geographics and all that stuff are pretty much non-issues if we can learn to communicate virtually.
Thank you. Yes, so congratulations on your course. And these materials, you can use them in an online environment as well as in terms of, when I talk about hybrid, all I mean by hybrid is that there is an instructor that's also supporting the instruction in addition to the material. That instructor can communicate with the student in an in-person physical class or in an online synchronous or online asynchronous. And we're actually going to be doing some experiments in the fall with a state school in the East that is going to be seeing if we can do sort of an accelerated learning study with just an online as a completely online environment. So I'll let you know how that goes. And so you can participate even if you don't have an in-person physical connection with students. Yeah.
Hi. While you were giving your talk, I actually signed up for one of the chemistry course, and I saw that it had many modules that would be useful to my course. Of course, my course is in a different order than the way the modules are presented, and I did sign up, but it asked for an instructor key. I was wondering how to get that, and is there a way to access each of those modules so that my students I can put it into my course at different places and then integrate it?
Yes, yes, and yes. So that's great that you already went and signed up for an instructor account. So the way it works is when you go to the website, you'll see 3 little boxes. One for if you're just an open and free learner, meaning you don't get credit, no one knows you're doing it, but you're learning. That's that person that has that drive to learn statistics. And then there's the academic student, and it'll ask you for a course key. If you want credit. And the way you get a course key is Carnegie Mellon doesn't issue course keys or credit for using these materials. The credit is issued by the institution or by the institution of the faculty who is using the materials to support their instruction. So the third box is I want to be an instructor. So if you create an instructor, you create an account, and that and saying I want to be an instructor, and it sends an email to our help system, and then we check to make sure you are an instructor, and then we change your account from a student account to an instructor account. Then we send you a bunch of materials so that you know how to use our instructor tools, which are just web-based WYSIWYG tools that allow you to do what you asked, which is select and sequence content out of any single content package, course package, or across course packages. Because some of the courses, like we have introductory statistics, we also have a causal and statistical reasoning course and an empirical research methods course. So some faculty get really creative saying, oh, I'm going to use these modules out of statistics and these modules out of causal reasoning and these modules out of economics and, you know, make my own little shmush. And so then when you select and sequence what you want to use, and you can date gate it and do all those kind of fun things, then the system will say, okay, assign a course key to what you've just created. And then you give your students that course key, and then when they get asked for the course key, they put that in. And what that does is it does two things. It puts them in the instance of the course that you created, and that it also then collects all their data to give to you as the instructor. Because otherwise, the system wouldn't know who to give all that student data to. You can, though, if you don't want to go through all of that, the whole course build thing, you can, on the open and free version, every single page of the course has a little button at the top that says create a link or email this to a friend. So you could, if you had a course in Moodle and there was just like one activity that you liked, you could just go there and click that button. It'll give you a URL, just slap that into your Moodle site, and the students will go there. And they don't need to create an account or register or anything by using that link. The downside, and so that's fine, you're welcome to do that. The downside of doing that is then the system, you won't get any information on what your students are doing or what they're learning, because the system won't have any way of knowing how to do that. So yeah. Anything else? I think. Okay. Enjoy your coffee break.